problem. All right, let me explain differential forms, the perfect 5-minute things to do. It's very difficult notion to understand. Here's a slick definition. I want you to distinguish these two things, f versus f of x. This is how I introduce my algebra and pre-calculus course. What is f? Here is an algorithm. Algorithm is not a number, right? Algorithm tells you what to do if you have x in it. And this one is that perform that algorithm with the input value x, then you get final value after you complete the algorithm, right? And this one is denoting that output value in there. But in mathematics, this is how we actually introduce in the earlier age that we understand numbers, but there is a procedure algorithm, but we don't recognize an algorithm as a number, right? But in mathematics, we recognize this as an element. That's the word they use. Algorithm is now an element. Now you add this to algorithm, you know what that means, right? And you can fog that algorithm, you know what that means, right? You have two algorithms, you can do these things and create a new algorithm. And then after you practice many times, many years, then you realize, okay, we accept this algorithm as an element, right? It takes long time to reach from numbers, juggling with the numbers, and to stage you recognize this as an element. Like if you're in linear algebra, linear transformation. That we recognize it as an element itself, outside of everything else. All right. Then we're doing the same thing in here. So we've been calculating this line integral. R is x and y and z, right? There's no parameterization. There's one point in there, right? But what we are doing with this line integral is that you introduce the parameterization into that. Then we have this dx dt, dy dt, dz dt. No problem. Right-hand side make perfect sense, right? But they introduce this new notation, dr dt. R is a position with no parameterization, but R is a parameterized. We're going to use this notation as well as sigma t. And when you're calculating this with a line integral, this how you parameterize it with a dt doesn't matter, right? Parameterization independence. So just like we threw away this guy here, they just capped it at f. They did the same thing. Throw away parameterization. Introduce this notation that misses the t. But whenever you have a parameterization, plug it in there and get actual thing that you understand, right? So think about jump from f of x to f. That's the jump we're making in here. Here's a thing, the real thing, but here's like thing missing, right? So we introduce this notation dr, dx with no t in it, dy with no t in it, dz no t in it. So it's like f of x going to f in there. This guy's called differential forms. This individual thing is called differential forms. Kind of ready to be parameterized, but not yet parameterized. That thing is called differential form. And they make a big deal out of it. 100 years of they playing with this thing as a new element in mathematics. And they opened up huge new area. This is a new entity that is introduced into mathematics are these guys. All right, so they also introduced this notation here. The dr is now formally like this, like dx, dy, dt, and this vector field has its own component in there, right? And dr, we accepted this is its own entity in mathematics, dotting this part and write it like this. That part and that part writing like this. So there's only x and y and z everywhere with this newborn element, the dx, dy, dz attached to it. And c itself is always described in terms of x and y. There's no t in it. But they write it like this. And whenever you have parameterization ready, and you go and replace all this thing with that parameterization, replace. And what about this one? Replaced with dx dt, right? And this one dy dt. That one replaced the dz dt. That once you put this t in it and this changes to A to B, everything is just calculus 1. You just calculate this thing with respect to t. But before you enter that parameterization level, they'd like to leave it like this, and they call it integration of an oriented path of differential forms. That's what they call. Some graduate students spent nearly half of the semester to understand what this thing is. And famous geometer once said that nobody knows what differential forms are. So it could be a murky notion. It's slick introduced like this, and I love this introduction. I've been using this introduction as well. So let's get used to this notation. Ready to be parameterized. That is called differential forms.